Hello, everybody, and welcome to the September edition of the Virtual Planetarium with my friend and colleague Pete Lawrence and myself, Paul Abel. And as ever, we will start with the inner solar system and work our way outwards into the grand, spectacular universe. That was quite a dramatic opening, wasn't it, Pete?
Yeah, I hope we can live up to it.
As ever, your enthusiasm for anything I do is really underwhelming. Okay, let's start off with the planet Mercury then. So it rises at the start of the month about 70 minutes before sunrise, which isn't too bad. And on the 3rd of September, it's fairly bright, magnitude minus 1.6, and sits about 1.6 degrees from the star Regulus, which is the brightest star in Leo. So that's quite a nice thing to catch. But then afterwards, it goes into superior conjunction and is quite a tricky object.
Yes, it is indeed. I think Venus is probably a better bet in the morning sky, actually. It's shining at the moment at magnitude minus 3.8, which is very bright. It's 1.4 degrees south of the Beehive cluster, Messier 44, on the 1st of September. Beehive cluster's had a lot of visits this year.
It has. It is clearly selling its wares because a lot of planetary callers keep stopping by. I'll tell you what I did meant to ask you. So I was, as you know, I was doing Saturn the other morning and I caught sight of Venus and it was incredibly bright in the dark sky. And I was wondering, if I'm not mistaken, you have captured shadows cast by Venus before.
Yes, I have.
I have never done that.
I have seen them. I've photographed them. I photographed them the first time, and I made a funny device out of a big cardboard tube and put a target on one end and a screen on the other end. And then I put that up, and I got a reply from somebody at NASA, actually, that said It wasn't the shadow cast by Venus.
Oh.
So I can remember talking to Patrick about it. And I said, I'm going to do it again. I need a target. And he gave me a stuffed Klingon toy, which I used as the shadow making target. But on that one, I took lots of shots of it was a wall that the shadow was projected onto over a sequence of time. So what happened was, as Venus set, so the shadow moved on the wall. So you could clearly see it was caused by something moving outside. And I did send that off to the same chap that said it wasn't the shadow cast by Venus. I never got a reply. I think it was probably the clanger that probably did it. He didn't think he was taking me seriously. But I've also been on a Northern Lights flight where we turned off the lights on inside the aircraft cabin. Venus was shining away, and I saw visually the shadow move in the plane.
That is remarkable. I have never seen the shadow of Venus. I think because I observe it mostly during the day, and by the time it gets to the evening, it's quite low down. And in the morning, when I catch it in the morning, by the time it's getting up above the houses, the sky's starting to lighten. So I've never had the opportunity to do it, but I think I shall have to make the effort to try and capture the shadow of Venus.
Well, this is almost planned as a segue into what's happening with Venus, because if you're observing during the day, you're well versed in locating Venus during the day. And on the 19th of September, Venus will be occulted by the moon between 12:48 and 14:07 BST, which is, you can work this out, can't you, during the day.
Really? So no, I'm still working it out, Pete.
So you've got to, if you can find Venus, you will be able to see that very narrow moon. It's a 5% lit waning crescent moon, which is going to be
tricky.
That's going to be difficult to see
I'll wager that Venus will be easier to see than the moon.
It will, because Venus has got a higher surface brightness than the moon, which is something. I mean, if you see the moon, you think it's shining away. If it's a big fuller phase of the moon, you think the moon's really, really bright. But if you put Venus next to it, and I've seen occultations before, you notice just how dim and grey the moon's surface appears next to brilliant Venus. So
yeah, it's not that surprising because, as you say, if you look at the moon when kind of it's quite gibbous and it's visible in the daytime, and against the bright blue sky, it's actually incredibly washed out. There isn't a lot of detail on it.
No, that's right. It is washed out. Yeah, but this is going to be exciting. because it's well placed. Venus is about, well, it's not particularly exciting because it's 11 arc seconds across and an 88% lit gibbous phase, so it's quite small as Venus goes. And it's really nice to see Venus when it's in its crescent form being occulted, but we're not going to get that here. But any occultation of a planet is worth going out for, and can be quite striking. I remember all the ones I've seen in the past, so, if it's clear, make an effort and go out there. But do be careful of the sun, because it's only 27 degrees from the occultation event. So don't go scanning with binoculars looking for Venus.
No, that's a definite no-no. It's best to do this with setting circles if your telescope has them. Okay, next planet out, Mars. Very straightforward, not visible.
No.
So it's given hanging around now and gone off and done something better. We'll have it again in a year or so's time. But the planet Jupiter is making a bit of a comeback. It improves through September and reaches a peak altitude of 28 degrees of around 0400 UT in darkness on the 1st of September. It's quite bright, shining at magnitude minus 1.8. And will now be steadily improving as we go on.
Yes, it will. It looks, at the end of the month, it's in deep twilight. It reaches 50 degrees altitude, which is
practically overhead.
Practically overhead, as we say. But Saturn is the star of the month, or the planet of the month, this month, because it reaches opposition, rising to a peak altitude of 34 degrees, as seen from the centre of the UK. So that's about a third of the way up the sky. As you say, you've seen it already. The rings are quite narrow at the moment with Saturn. So
yeah, and we're looking at the southern side of the rings now, which have not been really visible for us because of we've been looking at the northern hemisphere of Saturn, which has been tilted towards us. So I don't think I've seen this side of Saturn and its rings for over 10 years. It's been...
Well, it must be about 15 years, isn't it?
Yeah,
13 years,
is.
14 years, something like that.
Yeah, something like that. I noticed the other day when I stayed up to do Saturn, the rings are really quite a bronze brownish colour now. And I don't think this is an altitude thing, Pete, because when it was lower down further south a couple of years back, the rings were a sort of yellowish colour. They're now this sort of bronzy, muddy brown colour. And I think that's to do with the shallower tilt of the rings now.
Right.
They're much more narrow than they were a few years ago.
Well, they're going to get very narrow at the end of the year, of course. In September, the tilt angle is 1.8 degrees, but at the end of the year, well, sort of mid-November through to mid-December, it's about 0.4 degrees,
so
which is
narrow,
very, very good.
Yeah.
There are some interesting things, actually, because we'll mention this in a minute, but we will get a chance to see Titan and its shadow passing across the planet's disk this month. Now, if you're waiting until you get a good one of these, this is the one to look for. As I say, we'll mention it because with Saturn at opposition, Titan and its shadow are more or less in sync.
Well, I think so. This is a word of warning to you. Because it will be cloudy in Leicester on that day. So I expect you to be ready with your car and the C14 to load up so that we can travel to the ends of the earth if necessary to get this, because I have never seen a Titan transit. And this with its shadow being so close by is going to be quite a spectacular sight.
Yes, it will. Well,
I want confirmation that you'll be ready with the wretched car as well. We can't miss it. No,
we can't. It's such a rare thing to go for. It's the reason why I said well is because it's so subjective to the seeing.
Yeah.
If the seeing is wobbly, then you just don't get a good view of this event, which is remarkable. I've seen one shadow transit, Titan shadow transit, and the shadow was so subtle that it was almost not there.
Really? So that's odd, because Titan is quite a large satellite, and
yes,
you imagine it would cast, like Ganymede or Callisto on Jupiter, you imagine it would cast a very, very black, discrete, sharp shadow. Do you think it's the atmosphere, because the fact that Titan has a fuzzy atmosphere? Do you think that might be the reason why the shadow is...
No, it was our atmosphere.
Oh, okay, right. It's because the seeing was so poor.
Yes, that's exactly right. Yeah.
Okay. Right. Well, this will be a great event to look forward to. And, of course, there will be other Titan and shadow transits later in the year, but this is going to be one of the ones to get.
Yeah, we'll give you the details of that in just a moment. Let's just finish the planets then. We've got Uranus, which is now well placed as well. It achieves peak altitude of 57 degrees in darkness from the 22nd of September onwards. So this is a great time to go looking for Uranus. It's just south of the Pleiades, which makes it a lot easier to find than it has been over recent years. So there's no excuse now.
No, absolutely not. And then finally, the planet Neptune reaches opposition on the 23rd of September and can be found fairly close to Saturn, actually. It's shining at magnitude plus 7.8, so binocular or telescopic object. Currently, peak altitude of 36 degrees under dark sky conditions, which isn't too bad, but you won't see very much on it, even with a large telescope.
No, you won't at all. Okay, well, let's now dive into the specials which are happening this month. So on the 2nd, we've got the lunar X and the V, clear obscure effects, which could be seen on the evening moon, optimally around 11:41 p.m. BST.
And also on the morning of the 4th of September, this is the, as we've just mentioned, Titan's shadow transits Saturn's globe, visible in the twilight from 05:38 BST until Saturn sets at 08:16 BST. So the brightening twilight will add a degree of complication to it, I think.
Yes, it will.
I don't want to put people off trying, but that will make it a non-trivial, a difficult level of event to go for, I think.
We've got brightening twilight and you've got lowering altitude as Saturn sets, so it's not going to be a trivial task to see any of these events.
No.
That's the honest truth. But, you know, in astronomy, it's the things which you put the effort in for that are most rewarding.
Absolutely.
I can say that from personal experience, and I'm sure you can too.
Indeed, you're quite right. What else do we have? Well, on the 7th of September, Callisto, which is the outermost moon of Jupiter, reappears from behind Jupiter's disk at 04:46 BST, and then Ganymede's shadow transits the planet between 07:27 and 10:36 BST. So that's after sunrise. And again, that'd probably be a tricky thing to observe, although slightly easier than the Titan and shadow, because Ganymede does just cast a very sharp, dark shadow.
Yes, it does.
Onto
it's
Jupiter's disk. Yeah.
Okay, well, also on the 7th, in the evening, we have a total lunar eclipse. Now, you might get excited about this, but do you remember the one we had back in March, which it started to go into totality just as the moon set?
Well, I remember it for the fact that it was cloudy from here, so that's my...
It was cloudy in a lot of places, to be honest.
And you don't live that far from me. How is it clears around your house, but it's cloudy for me? I don't know. It seems...
That was clouded out for me.
Oh, that's all right then. Oh, good. I feel better.
Oh, that's all right. Oh, that's
feel
nice,
better now. I feel better now.
I feel much better, yes. Okay, so this one is the opposite. So this one, the moon will be totally eclipsed as it's rising. So it gets above the horizon and will be fully immersed in the umbral shadow. But then the umbral shadow starts to clear the moon. So you end up with this really weird, it's almost like a little banana-shaped moon as it's reappearing. And that's probably the first thing you'll see of it, because as the moon is rising totally eclipsed, it'll be darker than normal, and any haze or thicker atmosphere low to the horizon will hide it. And of course, you also get a reddening as something is low close to the horizon as well. So the moon will be red due to the eclipse and redder because it's close to the horizon. So you're probably not going to see the umbral bit as it just pops up.
No.
But what you will start to see is that little funny banana-shaped bit glowing away. And I've seen this before, and I was completely fooled by it. I was looking for a beautiful, totally eclipsed moon, and I just saw this really weird sort of cloud that was glowing there. And I was looking around, thinking, where is the moon? Where is the moon? And then it finally twigged, that was it.
Wow.
That was it, beginning to come out of eclipse. So just bear that in mind if you're looking for this eclipse.
That'd be quite interesting. I have never seen the moon rising in eclipse before, so this is something I'm quite keen to go and observe. But you will need to go find somewhere with a fairly clear, low down eastern horizon, I think.
Yes, it's just to the south of east. It's azimuth 100 degrees. So it's 10 degrees to the right, if you like, of the east point on the horizon. Get a nice flat horizon, and you do need clear skies to see it just as it's popped up. But you've got about an hour or so to view it. I think it comes out of eclipse. When does it finish? It's about an hour after it's popped up above the horizon. So you've got a whole hour to try and view something. So what we're going to get the best view of is really the second partial of this total eclipse. Yeah, the partial ends at 20:56 BST.
Well,
so just before 9 o'clock.
Yeah, I think that's worth doing. Definitely should be a very interesting event.
And of course, you've still got the penumbral part of the eclipse, which carries on for another hour after that, which is really difficult to see anyway. But, you might, if you're very keen on doing sketching, if you're an imager, then try and grab the moon just after it's come out of the partial phase. So say about 9 o'clock BST, 9 p.m. BST. Take a photograph of it, and then take a photograph of it an hour later using similar settings, and then compare the two, and you'll notice that they will appear subtly different.
Yeah, I should certainly look forward to it. And it'd be interesting to see just how orange it gets and how dark it is, because each lunar eclipse is actually quite different, and
it
depends on the amount of dust in the Earth's atmosphere. Okay, so on the 12th, Titan is eclipsed by Saturn's shadow from 0410 BST, and also on the 12th, the 67% lit waning gibbous moon occults the Pleiades star cluster.
That's a great thing to look out for if it's clear. I do enjoy that, seeing those stars disappear one after the other. It's quite a rewarding thing to look for. Okay, but on the 19th, early risers will get to see magnitude minus 3.8 Venus located just 0.7 degrees from Regulus. And the pair will be augmented by the presence of the nearby 6% lit waning crescent moon. And it's that moon which will then go on to occult Venus later that morning, which is what we mentioned earlier on. So if you want to find out details of that, then look in the magazine. There's a piece on that which I've written in the Big Three section. So
more details there. Yeah,
more details there.
On the 20th, Titan and its shadow are in sync. This is what we've discussed as they transit Saturn's disk from 0513 BST until Saturn sets at around 7 BST in the morning. And Saturn reaches opposition on the 21st of September, so that's really the best time to view it. Around this time will be a good time to look for the opposition effect. That's when the rings appear to brighten up. Well, no appearance, they do brighten up as seen from the Earth. Normally, when the rings are wide open, it's really, really obvious. But I think with the rings at such a shallow angle now, the effect will be a little bit more subtle than it usually is.
Well, it'll be interesting, especially as you've just said about the darkness of the rings now that they've started to tilt open again. Although they will be tilting close again at this time. But that's going to be something to look out for. I'm not sure what that's going to do, the opposition effect. I've never observed it at such a narrow ring angle. So again, these are important observations.
Yes, I haven't either, but I'm making a note to do that. So yeah, absolutely. What else do we have? On the 22nd, it's the Northern Hemisphere autumn equinox, which occurs on this day. And on the 25th, the largest moon of Jupiter, Ganymede, is eclipsed by Jupiter's shadow at 0508 BST.
There's a lot of moon events happening, and that's because of the narrow tilt angles of Saturn and decreasing tilt angle of Jupiter. So on the 27th, we've got a double shadow transit, which can be seen on Jupiter, involving the shadows of the moons Io and Europa. They'll pass across the planet's globe together between 0554 and 0641 BST. And then on the 28th, we're getting the other half an orbit round from the last Titan and its shadow transit. So we're getting Titan going behind Saturn's disk. So it's occulted by Saturn's disk at 0230 BST in the morning on the 28th. I've never actually seen that either.
No, I haven't either. It'd be something interesting. Yeah, but wonder whether you'll catch any curvature on the shadow on the planet if you image it.
Oh, blimey, that's going to be a tricky one.
It would be tough.
You might be able to, yeah.
It's an interesting one. And then finally on the 29th at 0026 BST, Io's shadow and Ganymede itself transit Jupiter's disk together. Io joins this little performance at 0138 BST, so it'd be quite nice to watch.
Well, that's quite a lot of things to look forward to in terms of special events, which hasn't left us a lot of time to look at the stars, but we will have a look at the stars quickly. Of course, we're coming into the autumn period, so the stars of autumn are back in force this month. The charge led, of course, by the magnificent flying horse Pegasus, which is upside down, and you only see the sort of torso of Pegasus. It's an odd constellation. The Great Square of Pegasus, as it's called, the very large asterism, isn't really a square, and the stars aren't particularly that bright, are they?
No, and I always remember the first time when I started in astronomy trying to look for this, and on the planisphere I was using, the square looks smaller and brighter than it actually is. When you first see it properly and then you've identified it, you think, God, it's enormous. It's a huge square, and actually the stars aren't that bright. There are some interesting things in the square of Pegasus, well, in the Pegasus constellation. I'm going to give a little shout out to a variable star I follow here, which is called RU Peg. It's a very interesting star, but easily fooled, because if you look at it at low power, there's a star nearby which looks like exactly the sort of star you're after compared to the Finder stars. You have to actually zoom in at quite high magnification because it's a little bit fainter than the nearby star and can lead you astray. But it's an interesting star to follow.
Right, that's interesting. That's the Great Square of Pegasus. No, I was being genuine there. I know.
Oh, really? I couldn't really tell, because rarely are you that genuine about anything I say in these podcasts. Don't know why I bother.
This is also, the Great Square of Pegasus is where the new general catalogue starts. NGC1 and NGC2 are located in there.
Oh, I didn't know that. Anyway, moving on. It's just call it a square. In actual fact, the top star, top left star, Alpheratz, actually belongs to Andromeda, doesn't it? So it's not really, shouldn't really be called the square Pegasus, should it? I
think it was originally part of Pegasus.
Right, and then got moved in.
And then I don't know who moved it. Oh, yes, I know.
I'm not saying it.
International Astronomical Union decided it would be a good idea to move it into Andromeda.
I'm not saying we're challenging their decision, but we are challenging their decision, because it's what is it now? Then the triangle of Pegasus, even though it's clearly a square.
The great triangle of Pegasus.
The great isosceles. It's not isosceles. It's this great scalene triangle of Pegasus.
That rolls off the tongue.
It doesn't. Okay. It just
yes. Well, as autumn rotates slowly into view, the dramatic summer constellations, of course, are being displaced to the west. But the higher constellations of summer are still visible for a good few months. The ones which are lower down, such as Sagittarius and Scorpius, are lost. But we've still got the summer triangle. Well, let's be honest, the summer triangle's still around until Christmas.
Still around in January, you can catch. So I don't know why we don't just call it the triangle, because it's visible all year round. Well, Altair did.
The triangle doesn't narrow it down, doesn't it? It's like triangulum, which is, it's 3 stars. What else would it be?
Yeah, absolutely. I mean, there are a lot of to be fair, if you take any 3 bright stars, any 3 stars in the sky, you can make a triangle. So it's not really going to identify anything helpful. But if you've got good skies, you can look out for the Milky Way, which passes through the Northern Cross or the constellation of Cygnus.
Actually, this is a good time to look for it. Yeah,
it is, and skies are quite dark by late evening. That's when the constellation's still visible. And I would recommend taking a good pair of binoculars. Don't have to be particularly powerful, and scanning down through Cygnus. The star fields are really quite spectacular.
Yeah, I mean, it's that darkness of sky and seeing the Milky Way, which is great. It's just that we've lost the very core bit, which is in Sagittarius, but that's okay. We can put up with that. I suppose you can catch it early evening if you've got nice dark clear skies. But the main part of the sky that you're looking at sort of in the middle of the night is the bit which is known as the sea. because it's got lots of watery constellations. You've got Capricornus, the sea goat, whatever that is.
I think you remind me of a sea goat, Pete. I don't know what one is, but I don't know.
No one's ever said that.
No, you've got a sea goat energy, a sea goat vibe. So I always think of you as a sea goat, the old astronomical sea goat of the sky.
Okay. I get that on a T-shirt.
I think you should.
I think I should. Yeah, so it looks, I mean, Capricornus it's an ancient constellation. It's a Babylonian constellation, I think. And it's a god, isn't it, that was supposed to have a top half of a goat and the bottom half of a fish.
Yes, yeah, very odd. It's a very odd concept. But yeah, I think you're right. Goes back to Babylonian star catalogues produced at around about 1000 BC. So it is quite a distinctive grouping. It's from the UK, where it's perhaps not so obvious because it's always quite low down. But if you go to further south, you see it. It is quite a nice constellation.
It's a very obvious triangle, isn't it?
It
a
is,
distorted triangle. It's as obvious a triangle as Pegasus is a square.
It's all triangles and squares, this particular one, isn't it? The constellation has a bright star in it called Alpha Capricorni. And if you look carefully at this star, you should be able to spot an equally matched close naked eye double with components of around magnitude 3.6 and 4.2, separated about 6 arc minutes.
They're actually not linked at all, are they? They're just in a line of sight effect.
No, so they're not really orbiting each other like a genuine binary star system would be.
No. Well, a little further to the south of Alpha lies Beta, which is a tighter double comprising a mag plus 3.4 primary and a 6.2 secondary, separated by just 2 arc minutes. That pair is best seen with binoculars or using a small telescope. But unlike Alpha, Beta is a true double, with the stars in mutual gravitational orbit around one another, separated in space by 1 trillion miles.
That's quite close, really, in cosmological terms.
It is.
Now, we do have a little globular cluster hidden away in this constellation. This is M30.
Yes.
And actually, quite a difficult one to catch if you're trying to do the Messier Marathon, if you started at the wrong time.
That's right, because you normally do that in March, and it's the one which is not visible. So get a view of it now, and then you'll be prepared, and then you can tick it off and say I've seen it earlier.
Yeah.
Okay. Well, above Capricornus, we keep with the watery theme by entering the constellation of Aquarius, the water bearer. It's a difficult constellation. It's big and sprawling, and I suppose there are 2 brightest stars in there, Alpha and Beta, but the most distinctive pattern is a little asterism known as the water jar, quite small, and it looks like a central star with 3 other stars at 120-degree intervals spaced around it. So in modern times, it's been given the more contemporary name of the steering wheel, because it looks like a little steering wheel.
Yeah, that's one of the few asterisms that looks like what it's supposed to. It is quite, as you say, Pete, it is quite a sprawling, faint constellation, but it does contain a few deep sky objects. We have NGC 7009, which is the Saturn Nebula, because it resembles a kind of tiny version of the planet Saturn.
Yes, it does quite well, actually, doesn't it?
Yeah, and the Helix Nebula, NGC 7293, although I have to say, visually, that's quite a tricky one to pick up because it's got a very low surface brightness.
It's massive, the Helix. It's one of the closest, actually. I think it's about 700 light years away, and it's over 1/4 of a degree in diameter. I mean, most planetaries are tiny, aren't they? They're
are.
Sort of a few arc minutes or measured in arc seconds across, and this one is completely the opposite. It's as I say, over 1/4 of a degree across, and that means that its light is spread over this large disk, which makes it more difficult to see. Have you ever seen it visually?
No, I did. I haven't looked for it for a long time, but I did once. Well, I had a smaller telescope, and I naively thought, oh, well, it's probably going to, it looks quite bright, it's quite large, and I just couldn't see it. That was with a 4-inch reflector at the time. It was the right area of the sky, but I couldn't see it. And I have a dim memory. I may have tried the university telescope on it a long time ago, And even then, it was such a faint smudge. I think it's one that's just too difficult.
It's a funny thing, isn't it?
Yeah, unlike the Ring Nebula, which is, really quite a striking object, even in a small telescope. You can see it looks like a little ring. You can see that. The Helix I've found very, very difficult.
I think it's odd because I've sort of had it in my mind that it's so faint that it's always going to be difficult. When I've looked for it in a half-hearted fashion rather than really going for it. And I think I've just looked and then convinced myself what I knew, that it was too faint to be seen, and then moved on. I believe I managed to image it with a smart telescope. They're quite good for this sort of thing. They can just mop up those things which you haven't seen visually. But it's a good one. Let's all go for the Helix this year and see if we can get it, because it is worth it. It's a beautiful object.
It is. It's very pretty, and long exposure photography really brings out some of the interesting structure within it.
Yeah. Okay, well, we've given you lots of food for thought in September. There are lots of events occurring, that eclipse and the occultation of Venus being particular highlights. So all that remains for us to say is wishing you clear skies, and thank you very much for listening, as ever.
Thanks all. Thanks, Pete.